Now you want to pay very close attention to what's given in the problem. This gives us our K and it tells us it's second order. Now there's my initial concentration, and in the first part it tells me I have minutes. So the first step that you want to do is write the equation that you're going to be needing. So I'm going to need my NOCL at time t. This is my integrated rate law for second order. Okay, so you want to make sure you grab the right formula. So that's going to be one step. Now, you've got to be very, very careful when you're working these types of problems, because take a look at this. My K is given in seconds and my time's given in minutes here. So you need to convert those minutes into seconds, and that would give us 900 seconds if you do that conversion. Now, with that under our belt, we're ready to start. So this is my unknown, NOCL at time t. Is the unknown. I'm going to plug in K, 0.048. Now that I've made sure that it matches with my t, I'm just ready to do a little bit of algebra. So really, that's all there is. These aren't hard as long as you realize that you're dealing with the integrated and not the differential rate law expression. So if I solve for that, my unknown is 0.0219 molar after 900 seconds. That's how much would remain. Now, the next one is similar, except it asks for time instead. But we're going to be using the same formula. So I have 1 over 0.150. Now, because I still am at my same 200 degrees, I have my same K. So I plug in K, my time is unknown, and then I still have the same initial. We're dealing with the same conditions. Now, if you do that algebra, you should come up with, and if I did my algebra right, 86.8 seconds. Not too bad. Again, the mathematics isn't hard. It's just grabbing the right formulas. Now, this next one kicks it up a notch, just a little bit. It gives us the rate constant like we had last time. What it doesn't do is give us the order. So we have to figure out the order. And this is where having units on the rate constant is going to give us that critical information that we need. So remember that the units are always time to the -1, molarity to the minus overall order -1. Now, if molarity is not showing up, that must mean that my overall order -1 is equal to 0. And if I solve for that, it means I have a first order reaction. So now I know what formula to pick up. So it's going to be natural log of C4H8. Now this is a minus KT plus the natural log of my C4H8 at time 0, my initial. This is at some defined time t. Now, be careful. This said that 1% decomposed. You want to be very careful to distinguish that from how much is remaining. What we want here in our formula is our remaining. This is how much is left over at time t. So this means that if 1% decayed, 99% remains. And so we need to take 99% of our initial. Unfortunately, they don't give us our initial. So we need to set up a mathematical relationship that we can use to substitute. And this gives me 0.99 times C4H8 at time 0. So 99% of my initial remains. Now, there's a couple of ways you can do this. You can actually substitute in here the number 1 and the number 0.99. I want to show you a slightly different way of doing this because the rearrangement of this is very helpful. If I bring this over to the other side, I'm going to have the natural log of A minus the natural log of B. Well, mathematically, that is equal to the natural log of A over B. So if I do that with my symbols here, I'd have my natural log of C4H8 at time t over my natural log of C4H8 at time 0 is equal to minus k. So that's 6.07 times 10 to the minus 10 times t. I think that's a very handy way. You will see this often. And if I'm solving for time, typically this is a little bit easier algebra, but that's your choice of how you want to do that. So I'm going to substitute in my relationship here. So then I'm going to have natural log of 0.99 times C4H8 at time 0 now, because I'm plugging this in. Now, you can't do this with a second order or a first order because they don't really cancel properly, but this does work with the first order because of the way the natural log functions play out in this mathematics. So that's equal to my minus 6.07 times 10 to the minus 10th t. And now what's nice is I don't have to make any assumptions about those. They cancel. And if I do that algebra and solve for that problem, I'm going to get time is equal to 1.66 times 10 to the 7th seconds. All right, that's going to be it for this video. And we have just a little bit left to do. The final aspects of this are pretty quick. So until we are able to pull this together again, this is signing off.